Okay, so we are live. Hello, everyone. Thank you for tuning in. We are really thankful to the Fuji team for selecting JUG Hyderabad as one of the stops for their virtual JUG tour. We have a really great talk coming up on migrating from imperative to reactive. Before that, I would like to pass on the baton to Girthian for giving us an introduction of the Fuji platform. Over to
Thank
you,
you.
Girthian.
Thank you so much, Sarajit. So, hello, everybody. My name is Geert-Jan. I'm in Amsterdam right now. And this is a stop on the virtual Fuji JUG tour. What we're doing on this JUG tour is promoting Fuji. And what I want to do is briefly, in 10 minutes, show you what Fuji is about, what we're trying to do, and how you can get involved. And then Nicolas will do a session on the topic of this stop of the tour. So Fuji, Fuji.io. Some people might remember way back in the past Java.net, which was a site run by Sun Microsystems. I used to work at Sun Microsystems and then at Oracle. Now I'm at Azul. And I've been leading this project, which in many ways reminds me of Java.net. So what was Java.net about? It was a site for users of Java. It wasn't focused on people developing Java itself, but it was focused on the users of Java. And in the same way, right now, we have the OpenJDK, of course, and there is a wonderful site, openjdk.java.net, which is focused on people developing the OpenJDK, but there is nothing for generic everyday users of Java. So what kinds of things would everyday users of Java want to have on a community site? Now, one area is, you can see here that we have two different themes. So this is the light theme and the dark theme. But one area that an everyday user of Java might be interested in is, now that there are so many different updates of Java, so there are quarterly updates, does anyone actually know what is in those quarterly updates? So on Fuji, you can find for each release, you can see here along the top, the major releases, you can see what has been added, what has been fixed per quarter. So right now I'm in April 2020 for Java 8, so last year, and here I can see all the issues that have been fixed in that particular update for that particular release. And also, to make it more manageable, I can go to the component view, and in here I may be interested in the client libs. And so now I can see exactly what has been fixed there, and now I can sort on priority, and I can browse through this. And if I like something, so I can look through the titles, for example, remove Marlin logging or Marlin renderer and all these different titles, and then I might think, hey, that's interesting, and then I can look at the issue itself. So from here I can click into the issue. Now, if I find one that I find especially relevant for me, I can vote on it. So you can just click on here, no need to log in. You just vote on it. And once you've done that, the most voted items end up on the highlights page. So the highlights page for each major version shows the fixes for that quarter that the community likes. And then we, as the Fuji community, add commentaries to those particular issues. So for example, this fix is entitled Integrate Marlin Renderer per JEP 265. Now, right now, you have no context about what that means. So we add here some explanation. So we say here, JDK9 switched to using the higher performing Marlin renderer. This is a backport of that feature to JDK8. Now that adds some meaning and some context to that particular fix. So that's what Fuji is about in a nutshell. We want to highlight hidden areas relevant for everyday Java users, and we want to analyze them. So what's another example of that? JVM switches. Does anyone know what the JVM switches in Java are and what the differences are between different releases? So here I'm in Java 11. So here I can see what JVM switches are new in Java 11 and which ones have been removed. And I can do this per release. Now that is thanks to Chris Newland, who is a Java champion, who has a site called Chris Who Codes. And on Chris Who Codes, you can find this information. But if you don't know about that site, you'll never find this information. So what Fuji is an integrated documentation platform for everything related to Java. Another example of this is the Java Almanac. So Mark Hoffman, another Java champion, has a site called javaalmanac.io. Now, if you don't know that it exists, you'll never find it. But what that site provides is a list of the OpenJDK distributions. Now, that's something that's changed as well since my time in Sun Microsystems. It's not just that there isn't just one single Java vendor, as it was just Sun. And it's not that there is a release of Java every couple of years. It's lots of different releases of Java and lots of OpenJDK distributions. And Oracle Java isn't necessarily the Java that you would use. And in many cases, it's definitely not the Java that you would use. And so here we list the different OpenJDK distributions and where to find them and where to download them, and potentially also comparisons between them. So this is a place where the different OpenJDK vendors can collaborate on providing meaningful information around their distributions. So that's where we started with Fuji. Now, the question you might have is, what does Fuji even mean in terms of the name? So it's a place for friends of OpenJDK. So the F of Fuji is for friends, and the O is for of, and the next O is from OpenJDK, and the J is from the J of Java or of JDK. So then you would have FOOJ, and you would have Fuji. So you wouldn't know how to pronounce it correctly. So we've added the A and the Y to help you pronounce it, and it's Fuji. And because there is a J in here, we have a nice connection to a logo, which is a bird, a J. And also, of course, foo is very interesting and relevant for Java developers, because you often have foo and bar in demo applications, basically as placeholders for real code. And that is what Fuji wants to be. It wants to be a placeholder for your interaction and your integration and your collaboration with the Java community. Now, beyond these kinds of integrations, this is really data-heavy integrations, and there could be more. You could think about forums, for example, Stack Overflow. The Java part of Stack Overflow integrated into Fuji is something we're discussing. But something completely different is a blog. Now, we didn't start by putting a blog together because, of course, there are many blogs in the Java community. But now that we have already these fixes displayed, and we have the JVM switches, and we have the OpenJDK distributions, and we have a forum coming, a next question to ask is, well, let's provide a place where people can share tips and tricks. So we have a blog called Fuji Today, and you are very welcome to be involved here. It's a WordPress site, so you simply get the user and password, and then you put your content in a queue, and Nicolas is one of the people that has put blogs here, and every week we together decide what goes on the site. And here we can see all the authors, so many people you might know about. So for example, who is quite well known here as well, Nicolas is a well-known Java person, Jean-Philippe Bempel from Datadog, Josh Juno, Marcus Hurt from Datadog, Matt Rabel, Raid Sang. So there are many well-known Java people who are involved here, but also some less well-known people. So we want to provide this as a place for people who are experts in Java, who want to share their insights, but also if you're a beginner, we need lots of beginner content. Now, a very interesting example of this is this article, New to IntelliJ, Me Too. Now, if you get started with a Java technology, you go to the site, you download whatever it is, and you see the hello world. And the hello world is perfect. It's 5 steps, everything goes perfectly. And then you try and follow those 5 steps, and everything goes wrong. And you almost give up, but in the end, you succeed somehow, and you're happy and you continue. So wouldn't it be nice if we had those kinds of experiences? Now, this is not something that you would find on the site of a vendor, how difficult it is to get started with a particular technology. But this is why we have Fuji. So here we can have the real hello world, how people really get started with different technologies. So if you've been struggling with a particular Java technology, come and publish your struggles here so that people, when they get started, don't do the standard hello world where they get frustrated on step 2, but they come to Fuji and they find out the real story, and they can struggle along in the same way as other people have. So that's one interesting opportunity. Another opportunity is the release notes section. Now, on the release notes page, here I can read about Payara's recent release. But while I'm reading about Payara's release, I also see, hey, there's been a release of WebLogic. Now, where else on the internet do you find release notes of Payara and of WebLogic? If you go to the Payara site, you'll learn about Payara. If you go to the WebLogic site, you'll learn about WebLogic. Here you find the release notes potentially of all the Java technologies. So if you're working for a particular Java technology company, consider publishing your release notes on your own site, but also on Fuji, because here there's cross-pollination and people come for one topic, but they learn about a different topic. So there's a lot of interesting directions that we can go with this. And something else, so we have authors, but we also have the concept of community managers. So a very good example here is in the security area. Now, the security area of Fuji is run by Brian Vermeer, who is a well-known Java security expert from Sneak. Now, Sneak is one of the organizations involved in Fuji, and it is a Java security technology place. So they know all about that. And he doesn't only publish his own content, but he also looks for other content. So if you have Java security topics that you would like to highlight here, then Brian is the person to contact around that. So each area of Fuji potentially has a community manager. And if you are an expert in a particular area, you could take on that part of Fuji. So basically, it's outsourced to you, and you would own that particular area. And you can then build up a reputation around that area in the Java community. Now, very quickly to wrap up, who is behind all of this? There is a Fuji advisory board, and that consists of these companies right now: Azul, Datadog, DataStax, JFrog, Payara, and Sneak. And the initiator of the project is Azul, and I'm from Azul. I run open source projects at Azul, and you see very small bottom left, sponsored by Azul. But it's a genuine community project where we want everyone to contribute. We would love to have content here from Bellsoft and from Red Hat and from Amazon and from all the JVM vendors, from all the different Java technology organizations. And these are the organizations that are really strongly behind this from the start, who've been involved in setting everything up. And you can see here, for example, from Sneak, Simon Maple saying, I believe Fuji has the potential to be the central resource for all Java developers. And also here, it's incredibly important for every ecosystem to have a core location for information to help grow the community and be an educational resource for all developers to use. Java has lacked this space for many years, and I'm really excited that Fuji is doing this. And also a nice comment here from Steve Chin as well. Fuji is an example of the strength of the Java community that is greater than any single company and is composed of active, passionate, caring individuals who want to share their expertise and help mentor the next generation of developers. So if you want to get involved, how to do that is there is a Fuji Twitter, of course, so Fuji.io. Please follow us on Twitter. We need as many developers as possible following Fuji on Twitter. And if you do that, what you will get is every day you will get a tweet, at least one tweet about a new article, which could be yours, a new article that we've published on Fuji on that particular day. There is, of course, also a Slack channel, and you're very welcome to get involved on the Slack channel and to discuss topics around Fuji or anything connected to Java. You'll find many Java champions you can learn from here, and beginners, and so on. So it's all about collaboration, and it's about bringing people together. And when I look at all the content here and at the authors, the author from here that you are now going to hear from next is Nicolas, who has quite some content as well from Hazelcast on his topic. And we would love for you to be involved in Fuji. There are many ways, entry points into doing so. If you are a blogger, you can continue blogging where you are, but you can repost, you can republish your existing blog content on Fuji to share it more broadly with the community. That's the Fuji story. Thank you, Sergit. You're on mute, I think.
Okay, sorry. Yes, I was on mute.
Sorry.
Speaking of mute, yeah. Thank you, Gertjan. I've shared the link of Fuji and the Twitter as well as the link on the chat box. And with that, I would like to welcome Nicolas. Nicolas is a developer advocate at Hazelcast, and he will be presenting today's talk on migrating from imperative to reactive.
Thanks, Regit, for introduction. Thank you, Hetyan, for your introduction on Fuji. And yeah, so it's my distinct pleasure to be here presenting this talk from imperative to reactive. And the two coroutines part is meant when I present this demo in Kotlin, and today I will present the demo in Java. Oh, it doesn't work, so I need to use my clicker, and now it works. So I'm Nicola Fränkel. As Regit mentioned, I'm a developer advocate at Hazelcast. Before that, I actually have a long history of being a developer or architect, or technical person. And yeah, this year it will be like 2 decades that I am working in software. By no means I'm a reactive guru, but I'm interested in how it works. Just the mandatory slides about Hazelcast. So my employer has 2 products. The first one is an in-memory data grid, and you can think about an in-memory data grid as distributed data structures. So instead of having a hash map that is limited to your own JVM, you can replicate data around or short the data on several nodes in the cluster. And the other one is Hazelcast Jet, and it's an in-memory stream processing solution. But I won't talk about either of them today. Today, I will talk about reactive. And reactive is actually already quite an old trend. In 2014, there was this Reactive Manifesto that was written. And the Reactive Manifesto states four properties of a reactive system. The first, it must be responsive. So when you query it, when you send it a request, it must respond in the timely fashion. And then it must be resilient, meaning that, well, there should be some kind of system that if one part fails, the rest continues working. The third property, it must be elastic, meaning that if the workload increases, it should still continue to do its job as much as possible. And finally, and that's the most interesting property in my opinion, we are talking about implementation detail here. It's about asynchronous message pacing. And the fun part about this Reactive Manifesto is most of the authors or the people who backed it were employed by a company called Lightband. And perhaps you know about Lightband. It's the company behind Akka and Scala. And Akka is based on the actor model. So the idea is that, well, it's inspired from Erlang, from the Erlang actor in the actor model in Erlang. And the idea is you have like actors, and they don't share states. They're just doing their stuff in their own way. And when they need to communicate with other actors, when they need to work together to accomplish some high-level task, they send message. The message is received by the actor. It's stacked or piled in a mailbox. Then it's up to the receiving actor to act upon it. And so the real main idea is no shared state. So every actor has its own isolation layer and message passing between 2 actors. And as I mentioned, the Reactive Manifesto had that in mind. But the fun part is that nowadays, I'm not saying ACA is not used or the Erlang platform and the actor model is not used, but we were, at least on the GVM, we are hearing a lot about something completely different. We are hearing a lot about reactive streams. And the idea behind the reactive stream is still to provide a standard for asynchronous stream processing, but with also this idea of non-blocking back pressures. So I will go to that a bit later. And there is a site about it, so you can find the links here. So the idea is we are not talking about the actor, we are just like focusing on a single thing. And the idea is when you receive a request, it's put in a like queue, and you've got like a single event loop that will like handle the event and dispatch it to the event handler. And the idea is that this event loop should not be blocking. You have this like single loop, and as soon as you block it because an event handler does something it's not supposed to do, well, the other events will pile up in the queue, and you don't want that. So the idea is really to have this event loop be completely always running and the event handler being asynchronous. And this is especially important on the GVM because, for example, some other architectures such as Node.js, they are single-threaded. So if you block on the event loop, well, nothing happens, nothing else happens. On the GVM, we are multi-threaded. So it will be hard to notice like right away that you blocked. And in the demo, I will show you how you can detect that. So why is reactive becoming so popular right now? Well, there are, like always, there are good reasons and not so good reasons. The not so good reason is scalability. Yeah, you might know about, hey, we must go web scale. So you have 10 users or perhaps 100 of concurrent users, but you must already think about going web scale. And in my opinion, it's not a great reason. That you can probably, like without being reactive, you can probably scale up to like, let's say, 1,000 concurrent users easily. Still, it's an argument that you might come upon, just like take it with a pinch of salt. The other, in my opinion, which is a much better reason, is that reactive you optimize your resource usage. Like you are running on premise and you are using like standard imperative code and you block. And well, it means that you will be like wasting some resources, some CPU cycles, some memory or whatever, and you don't care. And that's fine because the infrastructure is already there. You already paid for it. That's fine. Now, if you move your workload to the cloud, you will pay for those CPU cycles. You will pay for the memory. You will pay for everything. And so wasting resources on the cloud is not so great. So the idea is by going reactive, you will optimize resource usage. Now, since you are a developer or an architect, well, you're a technical person, you must always think that there will be like a trade-off. Huh? You will be optimizing the resource usage, but there are some downside to going reactive. And the first is it's a more complex mental model. Like it's easy to reason about your code when you go from line 1 to line 2 and line 3, and you call a method and then you return. And I mean, you can do the flow in your head. As a developer, that's generally what happens. Now, reactive is not about calling, it's about subscribing and having a callback. And it makes it much harder to reason about. And for the same reason, it's harder to debug because when you are running on a single thread, you will have all the states that of the calling functions, and you can go back. But if you have multiple threads that are running different things and you switch from one thread to the other, you might lose, depending on the tools you are using, you might lose this information. The third reason is you need to learn a specific API. So if you have been using Java for a couple of years, that means you have to relearn a lot. It's not impossible, of course, but in my opinion, it makes it much harder. Like, for example, sometimes I have questions. I go to my reactive guru and I ask him, hey, how should I do that? Because I know here it's something tricky. I shouldn't do it the usual way, but I don't know how. And so I need to ask somebody. And last but not least, remember the idea is to have no blocking calls. So you will have a reactive chain of subscribers and that subscribe to each other callback. But as soon as somewhere in the chain you put a blocking call, then the chain is not reactive anymore. So you should be very careful about this blocking code, and you should have nothing blocking at all. And here is the API. The API is actually pretty simple. I mean, the base API is really, really simple. You can see there is something called a publisher. Publisher will subscribe to a subscriber. The subscriber will have 4 methods. Now, unsubscribe, and you will pass a subscription. And here on the subscription, you can see the back pressure. The fact that actually, if you have a fast producing publisher and a slow consuming subscriber, you don't want your subscriber to be overflown by too much data. So the idea is you have this subscription, and the subscription, you have this request method that asks for, hey, I'm ready now, give me n more items. Then you have the on next, meaning that, hey, there will be a sequence of different items. It's fine, give me the next one. Here, it's the method that is called when there is an error, and that will finish the subscription. And here it's, hey, we have no more items, we have completed our job, that's fine. And this is successful ending. And because we will be chaining the calls, we need something in between. So here we have a processor that is both a publisher and both a subscriber. So that way, when you have processor, you can have a call chain. So those are 4 easy building blocks, basic building blocks. On top of that, you have different frameworks that popped up. The one I'm most familiar with is Project Reactor, and it's an implementation of Reactive Stream, and it adds additional blocks. So for example, here you can see that from a publisher, you have 2 different types of publisher. The first one is a Flux, and it can publish 0 to star elements. Mono, on the other side, can publish 0 or 1 element. So that's the idea. You have those 4 building blocks in reactive streams, and every framework adds additional stuff. Just mention that Project Reactor is led by Pivotal, but it has no dependency on Spring. On the other way, Spring uses Project Reactor. And if you know about the JDK, you might have noticed that since JDK 9, we have a flow class. And the flow class also has these 4 building blocks. You have the subscriber, you have the publisher, you have subscription, and you have the processor. No, what's the name? Okay, I forgot the name. And the processor, yeah. And they have the exact same signature. They are just in another namespace. They are in another package. And when you go on reactive streams, they tell you, hey, well, right now we will migrate and use those Java-based ones. It was written in 2017, and Project Reactor still use their own org reactive stream. interfaces, which is funny. You can still like bridge between them if you are using Project Reactor and Reactive Streams. You have this class that allows you to go from one to the other. And I need something to illustrate, so I have a demo, and I will be using a Spring application. And since version 5, Spring Framework supports reactive types. And it's a dedicated module called Spring Webflux with a dedicated package. And so the idea is, okay, we have like the legacy Spring MVC, we have Spring Webflux, and how can we implement it? Like the funny part is that Spring MVC, you can implement it with annotations. That's the usual way we have learned to do Spring MVC so far. But you can also use a functional API. So you can remove the annotations. You can use like routes, and I will show you how you can do it. And it's still Spring MVC. It's still blocking. It still relies on servlets. But there are no annotations anymore. And Spring Webflux, well, you have, of course, this functional API, but you can also use annotations. So there are multiple ways. And actually, if you look at the codes like at a glance, it's very hard to see if it will be Spring MVC blocking or Spring Webflux non-blocking reactive. So there are multiple paths you can take, and my idea is that since it's like what we start with, so we start from a Spring MVC annotation based, how do we get to Spring Webflux? The easiest way would be, hey, we just keep the annotations, we change the underlying engine, and we have Spring Webflux. As I mentioned, if you start your journey on Reactive, you will want to make it very clear that you are using Reactive. So the idea would be like, hey, let's start with Spring MVC annotations, migrate to the functional API, and then it will be a much smaller step to move to Spring Webflux, in my opinion. So I've talked a lot, sorry, and I would like to have some demo. You know, right now I've been doing this public speaking stuff for like more one year in this COVID situation. And so most of the time I'm talking to my screen, which is not super interactive compared to the situation before, where I went to rooms, I had feedback, I could see people, they could ask questions. So if at any point you've got questions, I will be very, very happy if you interrupted me, or at least if you wrote it in the chat, and then I could like read it. I will try to keep an eye on the chat to try to answer questions, and let's make this as interactive as possible. So as I mentioned, let's have some codes. So here I have my application, and this is my starting. I will just like move so I can see the chats. No questions so far. So here I have my application. It's a simple Spring Boot application. I'm using Spring Boot Starter Data JPA, Spring Boot Starter Web. I will be using some cache. So here I'm using an in-memory database, which is not very interesting in real life. It's just for fun. And I pretend that I need caching. So I'm using Hibernate and the integration of Hasselcast in Hibernate, so that when Hibernate does a query, it will populate the second level cache. And the next time I do the same query, I don't need to go to the database again. Let's see how it works. So I will launch the application. And here I can show you the code. So here I have like a stupid REST controller. I can query for like all entities. I can query for a single entity. I have a person repository. Since I'm using Spring Data JPA, I extend the JPA repository, and I don't need to write any code at all because it will be provided to me at runtime by Spring Data JPA. I have like simple like entity, and my application is, well, like normal Spring Boot stuff. And I will curl. So let's start. I will curl HTTP localhost 80%/1. Amazing, I can still code. I will make it a bit bigger. So here I have requested the first entity, and it gives me something because I'm using Spring Boot, and I have that data SQL stuff. And here that means that this script will be executed at startup time. So my database will always be pre-populated with some data. So here we can check, I requested ID 1, I've got Joe Dalton here, I've got Joe Dalton there. So it works as expected. Also, we can notice I have enabled the Hibernate statistics, and the Hibernate statistics allow me to see what happens. So here, for example, I told you I configured the second level cache, and the second level cache tells, hey, on this first request, you had one miss, of course, because the cache is completely empty. And you made the request, and we did one put. So now the ID 1 is in the cache. And here we made these JDBC statements. But now if we do the same requests, we can like query again. And of course, since the cache is populated now with ID 1, we have one hit, and there is no statement at all. So we didn't go to the database, which is super cool. Now what we can do is we can request all entities. And now if I request, and we can see that when you request all entities, then you have the puts of all entities in the cache. And now if we request, like, let's say ID 2, it's in the cache. So why am I telling you all about the cache that is completely unrelated? Well, I will show you that if you migrate to Reactive, at some point you will lose the cache, and we will need to like reconfigure it in like a very explicit way, because right now the cache is configured like that. Second level cache, it's here. This is like those 5 lines of configuration. It's how you enable the cache. And it's like really, really easy. Anyway, so that's the first step. The second step, as I mentioned, I would like to start moving to Reactive. And I will start baby steps by baby steps. So I want to move to Reactive by just now keeping WebMVC, but moving to a more functional API. So let's go there. And I have everything here. And I just want to have master. And here I will move to like WebMVC FN. So the like functional API of WebMVC is called WebMVC FN, FN for functional. What change does occur? So we don't have a controller anymore with annotations. We have like a class that is a configuration class now. And we don't have like get mappings, we have beans. So here we have 2 beans that return router functions. And here we use this like route function, and we say, hey, when you call get on this path, then, and that's where the magic happens, you say we return the function. Because actually when you are calling, when you are making a request to a web server, what you are doing is, well, it's sort of a function. You pass in a server request and you return a server response. And this is basically a function. You have something in and something out. There is like type server request in, server response out. So this is what we are doing. We are like passing the request, and we return like 200, and in the body, we will put all the entities that we have found, and Spring will take care of like making that JSON. So now let's start it with this, and let's check that it's still the same, so that the functional API didn't change a lot. It's just like how we code, but the result is the same. So I will call ID1, it still runs, we still have the cache, so there is one miss because we are restarted, so that the JVM went down, and since I have one single node in the cluster, everything went down. And here we can do it again, and we have one hit, so it still works fine. This is great. What we can do now next is actually we will, hey, I don't want to do that. I want to stop that. What we can do next is actually, I want to create a handler class. So here I want this to be in a dedicated class so that on one side I can have my routes, and on the other side I can have what the routing does. So here I create this person handler class, and I like copy paste it, what it does. And now my routing is much easier to read. You can see route.get person and handler.get all. So I delegated the function to a handler class. It still works. Let's check. So there is a question by Ashish. Hey, Ashish, we have seen many implementations of Reactive with different frameworks like Spring and Quarkus. Do you think it should be implemented different by framework? Looks confusing with many implementations. That's completely correct. As I mentioned, the problem of like you need to learn a new API, and every framework decides, hey, I have my new API. So it would be very great if we had one single API to rule them all. But since there is no governing body right now regarding Reactive, I think we might be stuck for some time with this issue. So you need to choose like your coding framework and stick to it, or you might learn different way. More or less, they will probably do the same stuff. Like you have RX Java, RX Java 2, Reactor. They mainly do the same stuff. The basic building blocks are pretty similar. Of course, the name of the functions will be pretty different, I'm afraid. So here we have one cache miss, and then there is one put. If we get it again, it still works. It didn't change everything. Router is fine. So the next step is pretty easy. Actually, what I want to do is to put all my routes under the same function, because it will be much, much easier to read. So I have now one single bean, and you can see here I have all my paths under the same route. So it depends on the size of your applications, how you want to organize your routes. You might have like all the routes with the same method. You can have like different routes for different areas of your application. It's up to you, but nothing mind-blowing. Now comes the real fun part. Now we have migrated entirely functional, and we will make this step. We'll just like replace like WebMVC by Webflux. And the changes are actually very small from the code part. Here, the POM, sorry, I wanted to say show def. The diff is pretty simple. You change starter web by starter Webflux. That's all. And now on the routes part, we change the namespace, we change the package, but the name of the classes, they are actually exactly the same. So here you can see you have return function, here you have server response, everything is the same, server request. We need to actually change two things. Now we will be returning not the real type, we will be returning this wrapper. Why? Because we want to subscribe on it. So we just wrap this server response by mono server response. And there is a slight change, because normally here, if we call body, we will also need to have a provider of values that we can subscribe to. Here, the repository is still sending real values, so we must like use body value instead. But afterwards, after the next step, we will use body again. So the change in the code are like very slight. It's just like namespace and packaging. Nothing mind-blowing. The code itself looks really, really, really similar. Let's see how it works. Too fast. And here I have the miss, I have the put. here I do it again. Oops. And here I have the hit. It works. Let's check for everything because this was a pretty big change. I still got everything. And I have my 5 puts. And now I can query the like 2. And I have no interaction with the database. I have 1 hit. I'm happy. Well, I'm happy. I'm not so happy. Now I've moved from Spring MVC to Spring Webflux. And so the front part of my application is reactive. But remember that the rest of the application is still blocking. So here I change the way I do stuff, but I've got no benefits because I'm still using Spring Data JPA, which like underneath uses Hibernate, which underneath uses JDBC, and with JDBC is blocking. So we replaced the blocking front part by a reactive front part that will be blocking in the end. So the next step is actually to say, okay, we need to be reactive on the whole chain. So we will also need to replace the data access layer. And this is much harder to do. This is no small feat. So let's see how we can do that. And then I will explain the changes. I was too fast. I was too fast. The first thing that we need to do is actually we need to replace like the starter of Spring Data JPA by Spring Data R2DBC. We remove JPA completely. And because, sorry, we remove JPA completely, we also remove Hibernate and the Hibernate integration with Hazelcast. And the driver that we use to access H2 needs to be replaced as well. So now we need to use a dedicated driver. Sorry. No more JDBC. We must use a reactive database driver. And this here, it's called R2DBC. So now that we have done it, there are not that many changes. Sorry. Here, we replace the JPA repository by a reactive sorting repository, but Spring Data we still like creates all the good stuff for us. So that's already something that is good. On the person route side, now we are returning our repository find all and repository find by ID are returning reactive types, so flux of person and mono of person. So now I need to, like here I can use body and I have something called a body inserter and it will subscribe to the reactive type. So I have this publisher and from publisher to like bridge from like the publisher to an inserter, but that's just quite easy. However, that was not so easy is now I have no more like easy way to first create the schema. Remember that before the schema was created automatically by Hibernate and JPA. Now we have to do everything ourselves. So I have to create this schema.sql and I need to also handle by myself the creation of the data, the insertion of the data. And I need to do that using as much reactive way as possible. So here, in order to access the database, I don't use the templates, the good old JDBC template. I use the database client. And then I must do them in order. So I must first, like here, I must like execute the schema creation. Then I should block until it's done. And then I should execute the insertion. And then I should block again. Otherwise, there is a risk that when I start using the application, the data won't be there. So here I must block in some way at some point in order to first create the schema and second to insert the data. There are some questions. So there is a question, when should one go with reactive? Yeah, that's a very good question. I was not clear perhaps in my introduction. You should go with reactive when you believe that the trade-off between the added costs of doing development in reactive, so having like developers trained in reactive, like spending time debugging your application, which will be harder. On the tooling must be adapted as well. Like when it's lower, or it's lower than the added benefits that, hey, like I'm already on the clouds and I can, by going reactive, I can perhaps like have 5% of like less costs every month. Then you check 5% of my monthly bill. I check how much more those additional reactive costs are in development, and if it's like better, then go reactive. Otherwise, no, don't go reactive. Again, this scalability stuff, probably your application won't like reach them until a long time. And you can start normally with imperative blocking stuff, and then, as I'm trying to show you, you can migrate afterwards. If you try to start from reactive from the start, if you already have your whole team of developers trained, that's perfectly fine. Most of the case, it's not the case. Is R2DBC available for common relational databases like Postgres or Oracle? So Postgres, yes. MySQL, I don't know. And this morning, I tweeted that I found that there is an Oracle R2DBC driver on GitHub. So that's a good way. That's a shameless plug. Please follow me on Twitter. And then you will know about a lot stuff. I think that's, yeah, I'm started now. And now I can do the same like query as before. And yes. But so I've got the response, but I have no caching anymore. There is no cache. Because again, I had Hibernate second level cache, reactive, removed Hibernate, removed JPA, removed integration with caching. I lost my cache. Okay, I'm reactive, but I lost my cache. It's fine for you. That's good. And I will do better, but just give me some time because I have a lot more to show you. I believe now that my code is completely reactive. It might be true, it might be not. Again, if you have one blocking call in the whole chain, then you actually are not reactive anymore. So the idea is, how do you ensure that your whole call chain is reactive? And actually, I just had to check out before running. So first I must stop, and then I must rerun. And there is something called Bloodhound. And Bloodhound, that's a play on words on Bloodhound. Bloodhound will actually check that your code is blocking, and is blocking on the not correct thread, because blocking on the event loop is not okay. Blocking on some other threads is perfectly okay. Probably it will be the case, like you will be to do file access or whatever. So you will need to block at some point. The idea is, if you block, it should be on one or the other thread, but not on the event loop. So Bloodhound will check that. And now, if I execute it, we can see that, I was not launching it. Bloodhound will throw an exception, a runtime exception, if it finds a blocking call or in the wrong place. So that's a good way to make sure that your application is correctly designed. So here it works because, yeah, I did my job nicely. And who is subscribing to the monoflux return type? If I understand correctly, it is the framework, it is the event loop itself, and up to on next, does it initiate a non-blocking write to the wire? Well, that's actually the framework that is subscribing to those types. So me, as a developer, I just need to provide them. And the framework, the whole engine, will actually subscribe to those types and, well, call the chain and do its own stuff. On next, so the idea is on next is generally when you have a flux, not a mono, and yeah, it will ask for, hey, give me like X items, I'm ready to deliver them, and so your flux will deliver them. I'm not sure if I understand the question. It's not about a blocking right. It's, yeah, just deliver them to me. And because you are returning a flux, your application should normally, I mean, the components that returns the flux should not be blocking. And you can make sure of that with block counts. If I'm not clear, please just like perhaps detail your question. I don't know if I was clear. The next step is we can use, and that was pointed out by a fellow developer of mine. Here we can change the way that we are actually creating the schema and initializing the data. We did that like using a database client, but Spring Webflux provides you the building blocks to do that. So you just need to use the API. And it goes back to my comments before that, hey, you should know the API. And if you don't know the API, you will probably do a lot of things yourself that are not necessary. I've added one additional step compared to the previous blocking way is here I will, like if I don't find something, what I want to do is I return like a dedicated status code. Like here I will return a 4.4. You can tell me, hey, it's not a 4.4, but I can still do it. Still, it allows me to illustrate my point. So here the idea is, hey, you don't use if else. You say, hey, like repository find by ID, and if nothing was found, so if the mono is empty, what we need to do is we will switch to an empty. And here again, you need to know the API. So you cannot do if, because then it will be blocking. And you say, hey, if it's empty, I will return like a mono of error that returns not found. So let's check how it works. Here I have this, it works. And here I have 10. And of course, I only have 5 items still in my database. And it returns me a 4.4. So that's an important thing to do. If you are doing reactive, probably you won't do a lot of if-else. You need to learn this new API that does it when it's empty. And the next one, and now we will be adding the caching again. So it's a Spring project, and we didn't have a service layer yet. So we will add a service layer, and this is a caching service. So between the handler and the repository, we will add this service in between. And what it does is, hey, we will find by ID. So actually, we will check if there is something in the cache. And if there's something in the cache, we return it. If there is nothing in the cache, we go to the database. And so this is what you would expect. And in find all, we just put everything in the cache. Now, let's do it, and we will see what happens. I have a 500 error. So why do I have a 500 error? Well, if we check the stack trace, we will see that we actually did something very bad, that we are doing a blocking call. We are doing a blocking call at this line. We are accessing the cache in like synchronous way. So there is good thing and bad thing. The good thing is because of blockhounds, and that's what I told you before, blockhounds like will transform those blocking calls in like in a place that was not meant to be blocking with runtime exceptions. So here we code our own coding mistake, which is good. And of course, the bad stuff is we did a coding mistake, but now we know that we cannot access the cache like this. What we need to do is to use the correct API. We need to use the reactive API. So that's the last step is here. The last step is now we are non-blocking. Now we do everything using the Reactive API that we have, the Project Reactor API. So what we will do is we will access the cache from a function, and because we are able to, Hazelcast gives us an async API, we will get that from like asynchronously. And we will transform this completion stage, this returns a completion stage, which is like normal standard Java async codes. And we need to bridge it to the Project Reactor world. And it's easy because there is this mono from completion stage. So if I do on next, meaning I have found something in the cache, I will just for fun, like writing down in the log, I will say, hey, like I have found this ID in the cache. And if I found nothing, then I switch to is empty, and I will find it or try to find it in the database. It can still fail because like I will search for ID 10. So if I found it, I will put it asynchronously in the cache and it write it down in the log. As for the find all, what I will do is, hey, like every time I have on next, I will put it in the cache. And so I will have the exact same behavior as I did before, but now I need to code it myself. So let's see how it works. I will start the application again. And I will try to curl it. So curl, as it started, yes, it has started. So here, I ask for ID 1. Of course, it returns me the correct stuff, which means that now Blockhound doesn't detect any problems with my code, which is a good improvement. And it tells me, hey, person with ID 1 set in cache. That's good. Now, if I ask for it again, it will tell me, hey, person with ID 1 found in cache. Now I don't go to the database anymore. And here you can see those are executed on like specific threads, not the main thread. And I can like try to query all items like before. And I didn't write anything in the log. But now if I query item 2, which I didn't query specifically before, all items should have been put in the cache. So normally item 2 should have been put in the cache. Let's check. Hey, yeah, person with ID 2 found in cache. Perfect. And now I'm back to my previous situation and everything is completely reactive. Amazing. And I think it's time for us to have a little recap. So the ID, I was too fast. The ID, if you are in the situation when you actually need to migrate to reactive, is I would advise you to first migrate to functional. And it will make things much more clearer than just using the annotation and changing engine. If you migrate to reactive, the benefits will be only seen if you migrate everything to be reactive. So remember, one single blocking call in the chain makes your chain blocking. So in order to ensure that, especially at first, but even afterwards, when you are become seasoned, I encourage you to use Blockhound. It's more work. Like I needed to add the integration with Hazelcast INDG by myself, but it's not impossible. It's just additional work. And if you are using Kotlin, which I didn't use, it will make things easier. But more importantly, I know that Reactive is very hype. Microservices are very hype. Kafka is very hype. Don't use anything because it's very hype. Use it because there is return over investments and it's cheaper. So thanks for your attention. You can read my blog. I also blog like weekly, normally on Sunday evening. You have new articles. You can follow me on Twitters. That's also nice. If you want to check the code, because I was perhaps a bit fast, everything is on GitHub. So I encourage you to like clone the code, to play with it and to check by yourself. If by any chance you are interested about Hazelcast, just join our Slack. And if you are a bit shy, but you still want to know more about other costs, we have free trainings. So now I believe that perhaps you have questions. Do you have questions? Any question? And thanks for the question. Yeah. How to invalidate cache after data change in DB? Well, actually that's a very, very good question. I encourage you to see another talk of mine, which is called an evergreen cache. So you can find it on YouTube. It's called a CDC, a change data capture use case, designing an evergreen cache. That's an amazing question, but unfortunately, it's a whole talk in itself. Ashish has a good question. Concurrency framework used here is fork join pull internally. I must say that I didn't check, so I cannot tell you. I don't know. Other questions? Yeah, sorry, that's the reason why I was a very bad or very good consultant, depending on who you ask. Is if I don't know, I can't, I just tell it. Do you have other questions? No question 1, no question 2, no question 3. So I thank you a lot for your time and attention. I hope you like this talk. If it's the case, don't hesitate to subscribe to the channel and to give an upward pointing thumb. And I hope that you learn something. And then I hope that the next time we see each other, it will be live somewhere over the world, and that this whole situation will have fixed itself. And I wish you a good weekend. Thanks a lot.
Thank you, Nicolas. That was really an informative talk. I've personally learned a lot, and I'm sure even the audience did. I'd also like to thank the team at Fuji for helping us organize this event. Please follow Fuji if you have not done already on Twitter. Their Twitter handle is @FujiIO. And also follow Jug Hyderabad, which is our Twitter handle is @JUGHYD. And stay updated. You'll stay updated with all these such kind of events in the future. With that, I would like to end the session. Have a great rest of the weekend. Thank you, everyone.
Bye, folks. Enjoy.